All right, welcome back, pre-calcsters. Yesterday, we were talking about exponential functions, and we're going to continue talking about exponentials. You do not have to write this down. I have a to the x right now. I have no idea what a is or x. If I want this thing to be decay, what do I change? A to the negative x. Now it's decay. What if I want it to be growth? What value of a might I pick? Greater than 1. So 2 to the x is something like growth, right? Do we ever deal with stuff like this? I don't think so, because think about what would happen. To the 1, it'd be negative 3, right? Okay? To the 2, it'd be a positive 9, and then it would just jump back and forth. We would not see just growth or decay. It would just start getting further away from the axis, doing this back and forth because of the way that negatives work. We don't include this one. This doesn't count. I don't know if we did this one. What do you think this would do? It's also decay. Okay, cool. Easy. Piece of cake, right? Kind of. Okay. Today, you guys get to learn about this wonderful new number, and I'm pretty sure that you've seen this before, but we're going to look at the number e. And it's going to sound unnatural, which is a very unintentional choice of words, but pun not intended. Turns out our topic today, we're still in 3.1. We are talking about the natural base. Okay. Now, it feels anything but natural, just so you guys are aware. It feels completely wonky while we're dealing with this. If you ever have something that continuously changes, like all the time, constantly changing, like literally everything in our physical world, you're going to encounter this number. It is going to show up in mathematics. If aliens are intelligent and they exist, they probably don't call it E, and they have no idea who Leonard Euler is. But if there is an intelligent race out there that's not human, they have discovered this number. Just like they have discovered pi, it will happen because it shows up all over the place. The good news is that we don't have to write the natural base every time. We're going to call this E. I'm going to stress lowercase e. Don't make it uppercase. It's always lowercase. Okay. Now, as we look at these, when we start talking about natural base, the base E is wonky. Right off the bat, we're just going to get it out of the way. First and foremost, we're going to say that the number E is approximately, and you'll remember up to like 3 or 4 digits of this, there's a button on your calculator that's E. Like, we don't really have to remember a ton of it. 2.71828, and I have no idea what the next number is. I saw a couple people grab their calculators just now. Do me a favor, verify to me that I'm correct. That means you get a find and type in E to the first power in your calculator. And Mark, does that calculator work? Yeah. Okay, about half of them are dead, so it's always a gamble. I think I'm right. Have you found the E button yet?
No.
Where is E, Dolan?
Second division.
Interesting. That is not where I'm going to look, but I think you're right. Okay. Alternatively, second divide works, but if you look next to 4, like to the left, there's a button that says ln. What's written in blue above that? E to the x, right? There's a reason that that exists. And I'm just going to verify, if we use second ln, e to the power of 1 is the same thing as e, and we do get 2.71828, blah, 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 blah. It shows up. Okay. It's legitimately 50% as to whether or not I'm going to remember this number with the correct decimals. When I'm doing calculations in my head, what number do you think I use for E, just to get a rough idea? Oh, that's way too hardcore. I'm not that good. 2. I just imagine 2 in my head and say, oh, I'm kind of close. Okay. Now, as we look at this, this feels anything but natural. And there's a reason that it's called this, because it shows up all over in the natural world. Immediately, we get to do a problem and see where this kind of shows up. So the natural base E, I'm going to just say it's Euler's number. Euler's number. If you would like to spend some of your time watching math videos that are really well produced and on YouTube and millions of people watch them, I would include, and you should check it out if you're into math stuff and you're interested in it. We won't go this far in depth, but if you look up 3 brown, 1 blue and type in E, you are going to find a stellar explanation. And there's a bunch of different explanations that you could do. 3 brown, 1 blue, the best pop math videos, like popular math that shows up in society that you'll ever find. Okay, now as we deal with this, just right off the bat, you guys have your calculators out. I want us to just check something real quick. We're going to do a quick example where I want you to evaluate the function, and we're just going to make it f of x equals e to the x. And we're going to do two things. I want you guys using your calculators or not using your calculators to give me a few values. I want to know what is f of 1 over e. Whoa, just kidding. F of negative 1, that's even easier. On B, I want you to find me f of 0. On C, I want you to find me f of 1. And on D, we'll go ahead and say f of 2. I'm okay with approximations. We'll go to hundredths places while we're getting these. This is just a quick check. Can you get this on your calculator? I would use the second ln button. Super weird question. Can I feel one of these just to see how firm it is?
Yeah.
Thank you. I was wondering if there were like pipe cleaners inside too. Nope. Now I know your calculator isn't going to give me the answer that I would write down here. What is f e to the negative 1? 0.3 what? Okay, I'm fine with that. I would never use this. I would use 1/8. Cool. What's, without a calculator, and you might have already done it, can you tell me what e to the 0 is? 1, guaranteed. What about f of 1? E, which is approximately 2.718, which is exactly equal to e, and f of 2, whatever e squared is. 2 squared is 4, so I bet it's like 6-ish. Is 7? That was unintentional that time. 7 what?
3, 8.
7, 3, 8 or 9?
8,
Okay. Okay. Now, if we get these, there's nothing to it, right? We just plug them into the calculator. Why did I pick these 3 numbers specifically, do you think? Because every table that we make with an exponential, no matter what the base is, that's what I want this to become. If we graph this, what is it going to look like? Well, let's check. 100%, it's just going to look like exponential growth. Here's 0, 1. And check it out. I'm going to do my scale differently because I don't want to have to use decimals. I don't mind going over to 1. If this is 1, e is about here. That's roughly where e would be, 2.7, which means I get the point 1e, and I get the point negative 1 and 1/8. Look, it looks exactly like the other graphs that we've been using. Nothing different, except this one naturally shows up all over the place when you model stuff. Now, when we do problems regarding or working with our exponential stuff, there's a couple different choices that we can make to how do we want to work it out. We're going to see the limit or the calculus-y part of this. You're going to do one more thing on the calculator for me. In your y equals, last example, just so we can see this, I want you to type the following into y1. I want you guys to type in y1 on your calculator. Inside of parentheses, we're going to use 1 plus 1 over x. And we're going to raise this to the power of x. 1 plus 1 over x to the power of x. Okay, now I'm going to introduce just a little tiny bit of calculus notation, but we've actually already seen this idea. I'll do the pre-calc version of it, and then we'll see the calc notation. What I want you guys to help me answer is as x approaches infinity, f of x, or this function, approaches something else. So we need to get this answer. Now, you can't type infinity on your calculator. It just doesn't work. But if I say we're getting toward infinity, It just means I'm picking values of x that do what? Like, give me any number first. 2. Okay, e to the 2. I don't know what it is, 7.39. Is that at infinity yet? I don't think so. 2 is not infinity. Can you get bigger than 2? Type e to the 20. Not e to the 20, I'm sorry, f of 20. Do we need to review how to do the f of 20 thing? Okay, do you guys all have that function typed into y1? Okay, go back to your main screen, second quit. On the right side, underneath the D-pad, the direction pad, do you see the button that says vars on your calculator? Vars, up top, you get some tabs. Y vars is one to the right. Go one to the right to y vars. I assume we all just typed in y1. Hit enter on y1, and now your calculator is saying y1 of what? And let's try it. Let's do 2 first, and shout out what you get. What's y1 of 2? So I heard 2 different numbers. 2.2. If we look at it, I'm just going to see where our... Oh, I know where your mistake is. You have to use y1. So if we do this again, I'm just going to go vars, y vars, y1. We have to do of 2. 2.25? Yeah. Okay, what about y1 of 10? You can do second enter on your calculator, and it will just re-bring that line. Just change your 2 to a 10. 2.59? Okay, so what was the first number? I'm just going to write them down. 2.25, and then we got 2.59. Okay, that was at 10. Go to 30. It's surely coincidence. That's at 30. Go to 300. And we're just getting bigger, right? I'm approaching infinity. I'm nowhere near infinity, but we never will be. 2.71, is that it? Go to 3,000. 3,000. Does it go any further than that? 2.717. Gosh. So hold on here. What do I want you guys to see? Anybody noticed it yet? What's E? As we get bigger and bigger values, what does this seem like it's getting closer to? E. This is the definition of E right here. If we go one more, and let's try 10,000, or one with a bunch of zeros, you're probably going to get a Stack Overflow at some point. But let's try y1 of like 10,000 or 10 million or 10 billion or 10 billion billion. I don't care how big the number is. Close to infinity. I have a pretty good feeling that your calculator is going to read this. Or it's going to never work again because I did not tell you to. I
got 1.
Okay. Does it sit? You got 1?
I got 1.
Well, congratulations. We broke math. Okay. Clearly, the calculators can't handle that. What we see here, do you guys agree that just with these numbers, 2.25, meh, it's whatever, 2.59, 2.67, are we getting closer to E? So this is the formal definition of E. This is it. Now, we're going to introduce one little thing. You will not have a ton of problems in here, at least until the end of May after the AP test. But we're going to look at this real quick. If this is f of x, and I'm just going to label it like this, we'll just say f. This notation we've used before. This is not brand new, right? As x approaches infinity. Do you remember when we used it? And behavior, right? The math and stuff. Check it out. This is so close to calculus that I don't know why we just don't use a calculus. We can write this in calculus. We use LIM to represent the limit as x. What is x approaching in our problem? Infinity. And we're looking at this function that we just named f. The limit as x for this thing goes to infinity for this function equals what number do we just say it becomes? E. This notation is calculus. This notation is not. Are they really that different? little bit. I still have x approaches infinity. The only thing new about it that makes it look like calculus that isn't yet is the fact that we call it, instead of as x approaches infinity, we just call it a limit. What happens? Does it limit somewhere? Okay, this idea, we have a nice way to have E. We can see the graph of it. We're going to do a couple problems. Now, the cool thing is whether you are super into business or super into nuclear physics, the same math gets tackled. Same exact thing. And that sounds like a crazy statement. It's not. Let's do a problem here. So we have this basic idea, at least of E. It's this number 2.718, and seemingly it shows up in this expression. Cool. Let's do some real application stuff. So this last little section, we'll just say it's here. Let's apply. Okay. Do we want, if I put money in a bank, like let's say I put $10,000 in the bank today into a savings account. If I come back in 20 years, am I going to take out exactly $10,000? If I wanted to cash out all of my account, would I take out more than 10,000, less than 10,000, or exactly the same? Why more? Yeah, why on earth would I ever let the bank use my money to make investments if they're not going to pay me for it, right? That's how banks make money. They take the money that I give them, they invest it into the stock market somewhere, hopefully safe. They make money off the money that I borrowed them, and because of that, they give me a small little piece of the profit. Cool. I make money by keeping my money in the bank. Now, when you start looking at the idea of opening up a bank account, if you have two different banks offering you something, how do you decide which bank you should use? The interest rate. Can we all agree that probably your goal is to make more money? So you want the higher interest rate on stuff. Natural. Okay. How do we calculate interest? Anybody recall the formula? So we have this idea called simple interest, which we'll look at briefly, so it looks like something you've done before. This is the way that if you ever get offered simple interest, don't take it. Okay, we're going to use a nice number. Let's use 100. Okay, we're just pretending, and we don't even have to write it down. We can talk about it. We'll write down the stuff here in a minute. Let's say I put $100 in the bank, and they say, all right, Holloway, I got you. I'm going to give you 10% simple interest. After 1 year, I get 10% of my money back, which means on that $100, I made how much? So at the end of that year, I have $110. Now, normally, the way the actual banks work is it compounds. It starts to build up. So I would take 10% of 110, not simple interest. It just says, hey, you put in $100 initially, we'll give you 10% again. They would give me $10 again, and I would just make 120. That is not very advantageous for me. It's great for the bank because as my account gets more valuable, they don't have to give me more money. Like, that's good for the bank, bad for the person. Now, as we look at that, that's super easy to deal with. We write this using the following. We would say A of T, and we're going to see this written a bunch of times. We will define it. We're talking about a savings. There's an A word that I would use there. I would open a savings account. There's the A. What do you think T represents? Time. So a savings account at time T. Turns out this one's silly as we look at it, but it's simply going to be equal to P. Any guess financially what P might represent here? Percent is a good thought. Principal. What is your principal balance? Your starting money. So however much money we put in is here, and then we make some little bit of interest over time. We can just simply write this as 1, that's 100%, plus R, whatever R, what do you think R stands for? The rate. Cool. And then all we need to do is say how many years did it work for? This is simple interest. Now, we don't do simple interest problems in here. Does this, whether you remembered it or not, does this look like something you at least have seen in algebra? Okay. Now, simple interest, whatever. Unfortunately, this is just once per year, and we always use the same amount. Kind of a bummer. Better than simple interest, we get compounding interest. Now, I don't know how much business experience you guys have. Who in here is not familiar with compound interest? Okay, easy to make sense of. In that first example, giving me $10 every year is just 10% of my principal. Nothing happens. If we compound it, and there's a few things that we'll look at with it, but if I put that same $100 in at 10%, and we'll say it compounds every year. Compound just means building on itself or multiple pieces. A compound fracture is typically one that sticks out of the skin. I don't know why that word is associated there. I was thinking there was a connection. Not anymore, apparently, once I started saying it. Okay, after 1 year, I would make $10 of interest on $100. Now, how much money is in my account? 110. So this next year, when I make 10%, instead of getting of that 100, it's now from that 110. And I now make $11 that year. So the year after, I have $121 in my account because I made $11 more dollars. And then $12.1 for 10% more. And then I just keep going up. And all my money that I make off of interest also starts to gain interest. That's what it means. Now, when you start looking at bank accounts and things like that, they're going to offer interest. It probably won't be exactly like this form, but we're going to write this formula and actually give the labels this stuff. So in the context of money, we would still talk about your account balance at some time. You guys hear something? Cool. All right. So here we are. When we're looking at this, we still need a starting amount of money. So we're going to go ahead and just label the crap out of these as we go. This A right here is your account balance. And we can be even more specific. The account balance at what? Or when? At time. What's your gut say? 0, maybe if I plug in a 0 here. Can we agree that whatever number I plug in is just the amount of time? I'm just going to say the account balance at time t. So however many times we're looking at. Okay, this is time then. What is this one again? It's our principal. Ooh, somebody who's better at this than I am. PLE or PAL? I think it's LE here. I think. If I'm wrong, I can probably just look in the text. Yeah, I'm just going to verify. Sorry. Gosh, all these just, they don't use that word. Maybe the authors also didn't know. Well, I know this is the way to spell principal. I just don't know if it's this one. Yeah, fair. See, now that I say this and I feel so confident, I bet it's AL. It's PAL. It is PAL. Yep. I don't know. Yep. Don't know why. Can't tell you why. I mean, we all spelled principal right. It's just whether we use the right word. Okay, here's a principal, which is just what? Give me the basic idea of principal. Love that word. Initial is what I'm going to put in there. Because maybe, just maybe, depending on the problem, we can just change this letter and we get the same thing. Okay, now this one is going to look uglier for just a second. And I'll go back to the blue color. We get inside of here, instead of 1 plus r, which is once per year, we're going to use 1 plus r over n. Okay, this time we're compounding. What do you think this r is? And it's a rate. And we're going to use this as a percentage. So if it's a 2% rate, what's the decimal that I put in? 0.02% per century or per 100. Cool. N, not even going to ask. This here, N, is the number of compounds per year. Okay, there's a little bit of ambiguity that might show up with problems here. The number of compounds per year. Now, this happens not just with money, but check this out. Let's say it compounds bi-weekly. What does that mean? It could mean every 2 weeks or twice every week. There is unclear there. I will avoid bi-monthly because of that, or bi-weekly. I don't like it because it's not clear which one it's talking about. One more thing that we get, and we don't have to define these ones again, NT. And maybe we will. N, I don't need. It's the same N. What did we say T was earlier? Time. Now, if we're talking money, and it's really important here because this is compound interest with regard to money, how's our compounds measured? Compounds per what? So we're going to have time in years. Okay, so we have this lovely formula for compound interest. Now, looking at these, it's fine and dandy. There's a better way to do it, but we should look at this type of problem real quick. Let's make up a fictional amount of money, and we'll do one example with this basic compound interest, and we'll get even better. Now, when we talk about compounding, there's a bunch of different options. I could compound once per year, which is, this is just 1r/1, and it's just this formula. Okay, what if I wanted to compound every month? How many times per year would it happen? 12. What if I wanted to do it quarterly? There's only 3 quarters in a year? So you might have said 3 months, and that's where it gets weird. 4 times per year, right? What if I said daily? 365? What if I said per minute? Okay, of course you don't know that. There's a song and a musical somewhere about this. 526, I don't know the words. It's Rent is the musical, just for the record. Okay, so here we go. How much money are we putting in? Let's do an example. 20 grand, cool. Let's put in $20,000 into, and we're just gonna say an investment, a fund. I'm not gonna write it, it's just some investment fund that we've been convinced and assured that we're gonna get exactly this interest rate over some amount of time. Earning how much interest? What's a good amount of interest to earn? You guys probably don't have a natural feeling for this. If you put money in a savings account, how much interest do you think they're gonna give you? 28? 5? 4 is much more realistic when the market is good and beneficial. Like 4 would be very high. I remember when I opened an account at Key Bank, they gave me 0.02 or something % interest, and I said, I'll take my money elsewhere. Like, it just wasn't good. Let's say that we're on the market instead. Like, we're not at a bank, we're on the stock market. Let's say it's 10%, which is pretty good for the market. If you're making 10%, you're beating inflation. Good. Okay, earning 10% interest, compounding. How frequently do we want it to compound? So this can be once per year, it can be once per month, it can be twice a year. Monthly, deal. Okay, here we go. We have 20 grand put into a fund that earns 10% interest that compounds monthly. I want to know, again, this is our pretend scenario, how long are we gonna let this money sit in this fund? Sure, I wanna know how much is it worth after 4 years. Okay, now for problems like these, typically, like, we can change numbers. The bigger the number, the more interest it makes, naturally, because 10% of 10 million is way more than 10% of 20,000, but we're gonna see the same thing happen. We're gonna pick out these values together, and you guys are gonna do the calculating. In this formula, let's just work it out. We are looking for A of t, right? And specifically, we are looking for A of how many years? So what should I put in for this t? 4. We are doing 4 years. There it is. Baller. Okay. What's the principal amount, the initial investment we've made? So here we go, 20,000. And I don't know why that's not blue. I'm just going to keep it all red now. 1 plus 10% as a decimal. 0.1. There's my rate per how many compounds per year? If it happens every month. 12. And then we're just going to plug in to the power of how many compounds again? Because it's the same n. 12 times 4. Now, this is just giving us how many months there are in 4 years, right? Because it happens every month. Okay, do me a favor, plug in that value. This is monthly. We'll go approximate, and we'll just round to the nearest cent. Yeah, I agree with you. I agree with you. You're good. Yep, you can do it right here. Okay, after doing nothing other than giving our money to this broker, how much money do we make? So kind of agree with you in your zombie unified voice. How much money do we have initially? So how much do we actually make? We just made 9,700, almost 9,800 for doing literally nothing other than giving the bank or this index fund, whatever it is, our money. Now, what's better than compounding monthly? And I'm going to write this number down if you guys will read it. It's 29 what? Okay, so check it out. So we'll get there for real. Like monthly's okay. If we wanted to do this daily, what changes about this? Let's say that we had another guy who said, hey, I'll do the same deal 10%, but I'm going to compound it daily. Are we going to make more money? Is it going to be a meaningful amount of money? Let's check. Okay, what changes? We're still doing 4 years. We still have 20 grand, but something has to change. What's N change to? Okay, so 365. And then up here, it's instead of 12 times 4, it's 365 times 4. With the understanding that we all know leap days exist and we're not going to account for them. Cool. Now, I bet we make a little tiny bit more. Like, I have no idea. A couple $100 more is my guess. I don't know. I didn't do the calculation, but you guys are. I hear way more button pressing than I was expecting. You have everything. All you have to change is this. I would have just second entered. I think so. Yours doesn't say, or?
It just says quit. I just deleted it.
Okay, so I'm just going to go up because it didn't really delete. 20,000.
Me too. It did. Wait, what?
Can I borrow this real quick? Okay. All right, so if you're getting different numbers, don't know why, but we're going to figure it out. Here we go. Looking at this. There's our first number. We have 20,000 times 1 plus 0.1 over 365. All of this raised to the power of what? 365 times 4. If you are, like, when I picked up your calculator, and it doesn't matter whose it is, I saw way more parentheses than I just typed. Why are we adding more parentheses? Do you guys type something different than this? Okay. The what? And maybe, like, we don't need it here, but when I type this in, I get 29,834. 29,834. Now, 100%, it's natural to expect more because we're compounding way more frequently. But notice what happens here. Instead of splitting this rate into 12 pieces and just doing it throughout the year, all we're doing is splitting it into 365 pieces, smaller chunks. Now, more of them, we get a little bit more interest, but it doesn't have to be super, nope, wrong one. It doesn't, like, it's not going to be huge. Could we do it by the minute as well? I don't know how many minutes are in a year, but if we did it by the minute, do you think we're going to see a little more? Yeah. Is it going to be a lot more? No, my guess is like $4 or $5 more once we get there, because that's even a smaller increment. Could we do it by the second? Could we do it by the millisecond, the nanosecond, all of that? Now, it turns out that some places, and in fact, every place realistically outside of financial institutions that aim to make money, in our world, in every experience that we have, stuff always stays the same and never changes at all, right? No, not even a little bit. Everything is changing. How frequently? Constantly or continuously. Would we agree with that? Like, real life doesn't just go in little every 365 or 1/365th. It just ticks, right? Everything moves continuously all the time. Okay, 2 things. We are done with this problem for now, and we have looked at simple interest and compound interest. We are going to look at a better type of compound interest. So the last thing that we'll have in our notes today, and a really terribly awesome joke that you guys are going to get to remember this forever and ever. Real quickly, have I ever told you a big long story that was a lie? Yeah. And I hope you remember that and hold it against me, but that famous Lakota chief is Sohcahtoa. I don't think you'll ever forget that. Cool. Okay, this story is not as involved, and it's not really a story so much. It's just a dumb thing that helps me remember it. We have simple interest. We have compounding interest. And then better than that, we get this idea of continuous. Why can't I spell? For some reason, when I write in all caps, my spelling brain just quits working. Is that right?
I don't know.
I don't know. I can't tell either, but it says continuously. I'm pretty sure it's right. Continuously compounding interest. Now, it turns out that it really doesn't matter if we're talking money with this or not. And tomorrow, we will have time to work on the assignment. I'm not going to give you homework tonight. There's poster painting after school for volleyball, for pep club. Go do that if I'm not giving you homework. Tomorrow, we'll do a bunch of problems dealing with money and radioactive decay. Cool. And it turns out they all use the same thing. Now, if we had gone further, and we already broke it down, but once a month is okay. Once a day is better. Is once a second or once a minute or a millisecond better? Okay, so do you agree that it's getting to be better and better for us as we make that increment smaller? Okay, eventually, and this is awesome that it works. We don't have to go super crazy into it, but I do want you to look at something. In your notes, how do we define E? We did it as x approaches something or with a limit, but what was inside of that expression? As x approaches infinity, it was 1 plus 1 over x to the power of x, right? 1 plus 1 over something to a, what number do you think is going to show up here as we let the number of compounds get bigger and bigger? Or maybe we let it approach infinity. What do you think is, say it again. It's E. The number E shows up right here. This is 1 plus 1 over x to some power. The number E shows up here. Here's the stupid thing that I want you to always remember. It's a okay deal if you get compounding interest. Like, it's an all right deal there. But if we get it continuously compounding rather than by some little increments in time, just infinitely small or infinitesimally small bits of time, I want you to remember this forever. We get, instead of just a good deal, if we have continuously compounding interest, our deal is not just good, but it's pretty good. Not pretty. If you get, so for real, roll your eyes, shake, hold on. Tyler, the creator, wrote a song about this here. It's the earthquake, because I want you to roll them eyes. Earth, right? Earth. Okay, as we're doing it, no, I want you to remember it. What kind of deal is it if you get continuously compounding interest? Pretty good. Why? Like, not pretty good. Nope, I'm from South Dakota. It's pretty good. Why do I say pretty good? Like, there's an obvious. Because it's pert. P-E to the R-T. It's literally a pretty good deal. Okay, so with this is how everything in the real world will work. I heard, where did it come from? My sister-in-law, I'm her biggest bully, or joke, I don't know, I mess with her all the time. Whenever I say silly stuff, I never look because it's going to make me feel bad, but do you guys roll your eyes ever? Yeah. Whether you physically do it or not, my sister-in-law, whenever she rolls her eyes because she does it really obnoxiously, I do this because it's like she's rolling her eyes so hard that it's messing with the earth spinning. Okay, I'm okay if you guys roll your eyes. If you get continuously compounding interest, what kind of deal is it? Pretty good. What's the formula for compounding interest without looking? Let's play the uncomfortably intense eye contact game. Have we played this year? Okay. Well, any guess on what's going to happen with the uncomfortably intense eye contact game? Yeah. Who's number 4? Wisha. What is the formula for continuously compounding interest? Go ahead. Sorry. P-E to the R-T. There's only one thing about that I didn't like. Do we have A times T?
Oh, no.
It's A of T. And you can just say A for realist, like whatever, that's fine with me. Hey, Lay, what's continuously compounding interest? A equals, or rather, before you look, it's what kind of deal is it? Why would you say pretty?
Because it's P and then R, P-E and then R.
Boom, you got it. If you can remember that stupid phrase, it's pretty good deal. It's so dumb, but you'll remember it. And I promise you'll remember it. Now, if we look at this, whether it's money or a different situation, let's just check. We saw that if we compounded every single day, we make $9,834 of profit. Okay, since you already have your calculators, let's just see if we do the same thing for 4 years, but instead of daily or by the minute or by the second, we just let it always compound. Let's see what we get from the previous example. And I'll just use blue, so it's up to you. If we're trying to find my balance after 4 years using the same numbers, I still put in 20 grand, but we use e to the r 0.1 times how many years? 4. What do we get with this? It will be more than 29,834, but probably not a ton more. 29,836.49. Now, it's a little bit better of a deal. But we're not going to say that. We're going to say it's what kind of deal? Pretty good. It is a pretty good deal because we're going to use this. Now, just so you know what we'll see tomorrow, if I write this, and you don't have to write it down, you can start packing up. If I write this expression instead, it looks different. That's it. Can we see that this is the exact same expression? AE to the KT. Same, right? AE to the K. Like all these match up. We're going to have like 4 or 5 versions of this formula that are the exact same formula. We just change the letters dependent on the context. All right. You cool cats and kittens, have a wonderful night. Bet, fam. Peace. Smash that like button, subscribe. Shout out to my Patreon.